Hi everybody, Dr. Mike Slater here, and today I am going to cover the concept of reliability, one of the most important concepts in measurement, one that's certainly relevant to methods, but will be relevant to essentially any time that we're measuring any sort of psychological variable or any other variable for that matter. So the objectives of this podcast are simply that you can define what reliability is and describe the difference between test-retest reliability, internal consistency, and Interrater reliability. Now, two of the most important terms in psychology, in measurement, are reliability and validity. And before I talk about reliability, I want to make sure that I distinguish the two. I'll cover validity in more detail in a different podcast. So reliability can be thought of the consistency or stability of a measure of behavior. Okay? Consistency or stability of a measure behavior. Is that measure consistent? Let's say that you were taking a personality measure, and personality is a variable that's thought to be relatively stable, right? So if you're conscientious right now, you should probably still be conscientious 2, 4, 6, 8 months from now. If the measure is reliable, then your score would be about the same if you took a conscientiousness test now, time 2, time 3, time 4, and so on. Okay? Validity, on the other hand, represents whether or not the measure is assessing what it's purported to. Okay? That is, validity is supposed to represent the truth. Is that measure actually measuring what it's supposed to? And there are a lot of different ways of assessing validity, and this is a simplification for the purposes of differentiating reliability and validity. So we'll cover that in a different podcast. But for now, think of validity as actually measuring what you're supposed to. So going back to that conscientiousness example, is that conscientiousness measure actually measuring conscientiousness? Okay, and there's a lot of different ways to figure that out, but for now just think validity means measuring what you're supposed to measure. Now, in understanding the relationship between reliability and validity, it's important to understand that reliability is a prerequisite for a measure being considered valid. That is, in order for something to be valid, it also has to be reliable. But a measure can be reliable without being valid. It can be consistent but consistently wrong. Think back to the conscientiousness example. Okay, let's say you take the conscientiousness test at time 1, time 2, time 3, time 4, and you get about the same score. Okay, it's a reliable measure. But what if, upon investigating whether it's a valid measure, we find out that that measure is assessing not conscientiousness, but agreeableness or intelligence or something else? Then we know that, well, that measure is reliable but not valid. Okay, so you can have reliability without validity, but you can't have validity without reliability. In order to really understand reliability, we have to understand very basically the concept of psychological measurement. Measurement essentially consists of two main components: a true score and measurement error. So the true score is essentially your real score, what your actual value is. If the universe is aligned and we can know exactly what your conscientiousness was, okay? If we can measure that without error, if we could, that's your expected score. If we can give the scale an infinite amount of times, that's your real score. Okay? Real life doesn't work that way. Of course, we're going to have measurement error, which is our deviation from the true score. And we can think about that mathematically. Okay? Your observed score on any given test is a function of your true score plus error. Okay? Now, typically, we only know, not typically, always, we only know the observed scores. Okay? We only know what you scored on that conscientiousness test or IQ test or whatever. But we can actually estimate your true score and reliability and your error, and reliability is one of the best ways of getting at error in measurement. And we'll talk a little bit about that. So I'll go through a couple of examples to kind of elucidate these terms. So a lot of times you can picture a dartboard when you're thinking about reliability and validity, when you're thinking about true scores and measurement error. So picture a dartboard. Let's say that the bullseye is your true score. So when we're trying to measure something, we're trying to get at the bullseye. Okay? So let's say, we have a psychological test, and you take that test, get a score there, you take the test again, get a score there, get a score there, get a score there, and so on. Okay? This test, the scores aren't consistent. They're not clustered in the same general place, and they're not near the center of the bullseye. They're not valid either. They're not assessing your true score, and they're not close to your true score. So this is an unreliable and invalid measure. Okay? Let's look at another one. So we have all of our scores, or our darts, or whatever you want to think of it as, clustered in one area. Okay? But nonetheless, the darts are not near the true score. They're not near the bullseye. So this is a reliable measure, but it's not valid. Looking back, though, let's say that we have another dartboard, and you take multiple examples of a test, and they all land near the true score. Okay, this represents both a reliable and a valid measure. Okay, the administrations are as close to the true score as they could possibly be, and they're consistent. They're consistently grouped in that area. Okay, so we know that it is a little bit more valid. Let's go through another example. Let's say that we're using a scale, okay, as an example, and let's say that we're trying to get at my true score of weight. Let's say that my true score of weight is 205 pounds. Okay, we would expect that a scale should be able to accurately measure weight and be consistent in terms of its measurement. So let's say on day one, I step onto the scale and it says 210 pounds. Okay, it's possible that I gained 10 pounds that day, or 5 pounds that day. The next day, I step on a scale and I weigh 197 pounds. Okay, maybe from day 1 to day 2, I lost 13 pounds. Day 3, I step on the scale, 227. Well, first of all, I want to hang myself because I gained, what I perceive as 30 pounds in a day. But, I start to think, well, maybe this scale isn't very reliable, isn't very valid. There might be something wrong with my scale. Okay, the measures aren't consistent. They're not measuring what they're supposed to measure. They're nowhere near my true score weight. So I go and I get another scale. Okay, I step on that scale, day 1, 373, day 2, 372, day 3, 374. Well, it's consistent, but look at myself anyway in the mirror. I can't believe that I weigh 372-ish pounds. Okay, so at the end of the day, I say, well, that's a reliable scale. The measures are consistent, but it's not valid. It's not assessing what my weight is actually supposed to be. So I get another scale, and it takes its time getting up there. The scale at day 1 says I weigh 205, day 2, 206, day 3, 205. All right, that scale is relatively accurate. It's measuring my weight reliably. Okay, it's clustered together across those 3 days, and it's measuring close to what my true weight should actually be. Okay, and so the examples that I gave, the dartboard, the scale, these are, of course, examples for the purposes of illustration, but you can think of really any sort of psychological measure, these concepts, reliability and validity being applied to any sort of psychological measure. Intelligence tests, personality tests, ability tests, and so on. And the reliability and validity essentially mean the same thing. Now remember, an observed score is equal to a true score plus measurement error, and reliability is one of the best ways that we can assess measurement error. If we have a highly reliable measure, it's going to have lower error. Okay? If that measure is consistent, it's going to have lower error. And so your question is probably, how do we assess reliability? Well, we have multiple types of reliability. Okay, we have many different ways of assessing reliability, and each of these methods have both pros and cons. And I'll go through the 3 methods over the next couple of slides. The first type of reliability is test-retest reliability. That's when you assess a measurement by using the same individuals at 2 points in time. Okay? So let's say that you have a math test. You give the math test to a class at time 1, then a month later you give the math test to the students again at time 2. We would expect that that from time 1 to time 2, these 2 math tests are highly correlated, are strongly related. Okay, and if they are strongly related, then that's good evidence of reliability. Now, test-retest reliability is certainly not perfect. It's vulnerable to artificiality, where people might remember how they responded on exam 1. So maybe a student knew they did well on the first math test, and so they kind of remember how they responded to certain items and did exactly the same thing at time 2, as opposed to working through the problems again. And they end up doing, equally well because of that. Additionally, test-retest reliability is vulnerable to maturation because, well, over time people can change. Maybe from time 1 to time 2, the students were exposed to more math-related concepts and they started to understand the material better simply due to time, so they did better. So the test doesn't seem as reliable because from time 1 to time 2, student scores tended to increase. That's not so much an issue with stable variables, individual difference variables, personality variables. Those are all thought to be relatively stable, and so test-retest reliability is more appropriate when you're looking at variables like that. The second kind of reliability is internal consistency reliability, and this is the most commonly reported type of reliability. If you take a measurement class, you'll talk about this in much more depth. But this will give you sort of an overview of what it is. Now, when you're looking at a psychological measure, typically these measures consist of multiple items. Like a conscientiousness measure might have 10 items. An intelligence test might have 150, 200 items. And if these measures are, reliable, they should all be grouped together and measuring the same thing. So we would expect that each item would correlate with one another, or that parts of the measurement scale, parts of the test would correlate with other parts. And so we developed, not we as in me and anybody else, but psychologists developed internal consistency reliability. There are 3 types of internal consistency reliability: split half, Chromebox Alpha, and item total correlations. Split half reliability is when you correlate one half of a measure or a test with the other half. Okay? So let's say we're looking at that same math test. We give it to the class. We have their measures. We have their scores, rather. What we can do is we can break the test in half and correlate one half with the other. Now, given that, in a particular math test, the latter questions might be more difficult than the earlier questions, what we can do is we can randomly select, the items for the first half and randomly select the items for the second half. So that way we have 2 relatively equal halves. And if those have a strong relationship with one another, we know that they're reliable. Chromebox Alpha is probably even more common in split half reliability. It's really simple to calculate on any statistical programs. Essentially, it's trying to determine whether or not each item is correlated with every other item. Okay, so you would expect on a conscientiousness measure that the first item should correlate with the rest of the items. The second item should correlate with the rest of the items. Okay, and therefore, if you have a consistent measure, all the items should correlate with one another. If you have, with this measure, of course this is really useful, and it's a really quick and easy way to tell whether or not a scale is measuring, all the items are measuring the same thing. This measure, of course, isn't perfect because whenever you have more items, a scale is always going to be more reliable. So reliability is going to be a function of the number of items. Chromebox Alpha is really only useful when you have between 4 and 18 or 4 and 20 items. Anything above that, you're going to have almost perfect reliability. The final way of testing internal consistency is to look at item total correlations. That's when you look how well each individual item correlates with the total score for that particular scale. Okay? So how does item 1 correlate with the composite of items 2 through 10? It's very similar to Chromebox Alpha. Oftentimes Chromebox Alpha and item total correlations are used hand in hand with one another. And it's really useful for identifying bad items. So if there's one item that doesn't correlate with the rest of them, it will have a low item total correlation, and it might not be measuring the same thing. So item total correlations are often used to identify bad items. They're often used to shorten scales and really key in on the items that are most important. Okay? Now, I want to talk a little bit more about Chromebox Alpha and item total correlation. Chromebox Alpha, there's a heuristic that your Chromebox Alpha should be around or greater than 0.70. Okay? That's sort of the heuristic that most people adhere to. Now, this is, again, really based on the number of items that you have. If you have more items, you're almost going to automatically have a higher alpha. So alpha has to be interpreted in terms of how long that scale is. So if you have a 4-item scale, 0.70 is actually pretty good. Okay? If you have a 20-item scale, 0.70 is actually pretty bad. So when you're interpreting alpha, you need to make sure that you're taking into account the number of items that you have, okay? Or if you're reading a research paper and you see alpha of 0.7 is reported for a 25-item scale, you have to think, well, something might be wrong with that scale, okay? So just be sure to be critical about that. Item total correlation, typically anything greater than 0.6 is considered to be relatively good. So if an item has a correlation of 0.60 with the total score for that scale, that's considered to be pretty good, and that's an item that will probably be retained within that scale. Now just remember that when you're doing an item total correlation, it only tells you how that one particular item correlates with the total scale. So you have to make sure that you look at the item total correlation for each individual item. And if you end up adding or dropping items, you'll have to recalculate item total correlations because, of course, the total is going to change and you have to look at it again and again. The next type of reliability I want to talk about just briefly is Interrater reliability. Interrater reliability is used in situations when you have multiple people rating individual behaviors, and maybe this is typically seen in observational studies. So say I'm observing behaviors in a primate lab and somebody else is observing the same behaviors. We want to make sure that our coding of our behaviors correlates highly. Okay, make sure we're looking for the same thing. You might do this when you're coding interview questions in a qualitative study. Okay, you're coding different themes. You might be able to calculate Interrater reliability there. Essentially, this is just correlating the data between observations of raters, where you expect that your raters will essentially be measuring the same thing, and you expect a high correlation. There is a particular type of Interrater reliability that's been used more and more frequently in research called Cohen's kappa. Cohen's kappa is essentially measuring Interrater reliability but subtracting random agreement, and it's a relatively easy calculation to do, and there's calculators available online and you can do it in statistical programs. But what it does is essentially maybe I'm observing primate behavior, as is somebody else, and we both code that the primates are being social with one another at a minute and a minute and a half. We both code that they're being social with one another. Well, there could just be sort of random agreement there. And so Cohen's kappa takes that into consideration, and it adjusts the correlation based on sort of this random agreement. All right, so to summarize, just remember that reliability of measures do not indicate whether a particular measure is accurately measuring the variable of interest. Okay? Remember, a measure can be highly reliable. Okay, you might have a high test-retest reliability, a high Cohen's kappa. You might have a scale that has high Chromebox Alpha, but it might still not be measuring what it's supposed to. So think about the scale example that I gave you. Okay, again, a couple of the scales were reliable but not valid, not accurate. They weren't measuring what they were supposed to. So even if they had high measures of reliability, high Chromebox Alpha test-retest reliability, they still wouldn't be considered to be valid. Or think of, let's say that my buddy Jimbo came up with Jimbo's big measure, O intelligence. Okay, it might yield a reliable score, but chances are Jimbo, being the foresting man that he is, may not actually be developing a measure that's assessing intelligence. Maybe it's assessing forest intelligence or understanding how to capture a squirrel with a rat trap, but it might not be measuring intelligence as we know and conceptualize it. Okay, and just to look at this a little bit differently, factorial representation of reliability and unreliability. Let's say that we give an IQ test, okay, and typically the average IQ score is 100 with a standard deviation of 15 on either side. Let's say over here is the number of scores obtained. Well, if a test is reliable, most of the scores are going to be clustered together. Okay, if a test is unreliable, most of the scores are going to be relatively spread out. Okay, just looking at reliability a little bit differently. So what I want to do here is give a few different examples of research situations. I want you to think about which measure of reliability would be most appropriate. So let's say that we measured conscientiousness along with several other variables in a single survey. What measure of reliability would you use? Typically in a situation like this, you would use some sort of measure of internal consistency. Okay, you don't have multiple time points, you don't have multiple raters, so you would want to measure internal consistency, and specifically something like this. Typically you'd expect that Chromebox Alpha would be reported. Next situation, let's say that we measured extroversion in students when they were in grade school and high school. What type of reliability would be most appropriate? Well, in this situation, you can use a couple different types of reliability. You can measure internal consistency at time 1 and internal consistency at time 2. Okay, just Chromebox Alpha at time 1 and time 2. But you can also, in an effort to determine whether or not the measure is stable, assess test-retest reliability to see whether extroversion in grade school correlates with extroversion in high school. Next, let's say that multiple raters observe several children and assess neuroticism. Here the obvious answer is in Interrater reliability, where we have multiple raters and we can correlate their scores with one another. We can take it a step further, and depending on how the raters are coding neuroticism, we can calculate Cohen's kappa. Okay, so that way we can take into account random agreement. Next, let's say we're developing a new scale on emotional reactivity and we give it to adults at 2 different time points, time 1 and time 2. Which would be most appropriate? As with the second example, we can measure reliability in multiple ways. We can again measure Chromebox Alpha of the scale at time 1 and at time 2, and then we can correlate time 1 and time 2 scores together to get an assessment of test-retest reliability. Now, the last thing I want to talk about is how you report reliability. Let's say that you are measuring Chromebox Alpha. In Chromebox Alpha, you're going to report for almost every measure that you assess, okay? Almost every measure. The almost takes into account when we have 2-item measures, which Chromebox Alpha is not appropriate for. You typically just report the item total correlation or the correlation between those 2 items. And situations where you have single item measures, you know, how on a scale of 1 to 10 would you rate your overall health? Of course, if you don't have multiple items, we can't run Chromebox Alpha. But if you were going to report alpha, you would say something like the measure was shown to have adequate internal consistency, adequate Chromebox Alpha, and then in parentheses you would use the symbol alpha and equal to whatever it's equal to, okay? Let's say that you use test-retest reliability. Whenever you have a situation like that, you can report it. So you can say something like test-retest reliability showed adequate stability of the measure over time, where you would say where the correlation is equal to correlation represented by lowercase italicized r equals 0.72 in this case. Interrater reliability would be used whenever you use multiple raters. So you could say something like Cohen's kappa was calculated to determine interrater agreement and the resulting value, and kappa is represented by k, equals 0.93, indicated very strong agreement. Okay, so this is how you report reliability. Of course, there are other types of reliability, but the same general rules apply. Say what type of reliability you're measuring and then give the statistic, and you are good to go. All right, so that essentially wraps up this podcast. If you have any questions, you are free to contact me and let me know. Have a fantastic day.